So we're going to do the discriminant formula today. So the formula for discriminant is on your formula sheet, but it's b squared minus 4 times a times c. It's important that the b goes in parentheses, especially when it's negative. We want to make sure that we can get it to be a positive when we square it. And the discriminant tells us how many solutions the quadratic formula has. So we're not doing the whole quadratic formula, we're just finding out how many solutions it has. And if the discriminant ends up being a positive number, it'll be 2 real solutions. If it ends up being a negative, it'll be 2 imaginary solutions. And if it ends up being 0, it's 1 real solution. So you might be wondering, what in the world does imaginary solution mean? Essentially, if we had a graph, like we've done our graphs before, a graph that never hit the x-axis would have 2 imaginary solutions, versus a graph that crosses through the x-axis would have 2 real. And if you have a graph that hits the x and then it bounces right back up, it would have 1 real. So we want to make sure all of these problems are set equal to 0 before we plug into the discriminant. And then we can label it with our a, our b, and our c. So our a is the one with the squared, our b is the one without the squared, but with the variable. And the c is the constant, or just the number. We want to remember we're only going to be plugging in the numbers. We're not going to be plugging in the letters. So we're going to take our b squared, and then we're going to subtract our 4 times our a, which is our -2, times our c, which is our -3. And we can put this whole thing into our calculator. Just make sure you use parentheses, a subtraction sign here. And anything that's in parentheses, we want to use the negative button. If you want to use PEMDAS, you can do exponents first. So that would be 49. And then you could do the multiplication at the same time or separate. So you can do 4 times 2 times 3, which is 8 times 3, which is 24. Since it's a negative times a negative, we usually think positive, but then there's another negative being multiplied. So a negative times a negative is a positive, and a positive times a negative is a negative. So 49 minus 24 is 25. And if you get a positive answer, that just means it has 2 real solutions. So we're going to go ahead and write 2 real next to our discriminant, since the instructions ask us to not only find the discriminant, but to state the number of solutions in the problem. So all of these are pretty much the same, except some of them are not set equal to 0. So you want to move everything to the left, like we've done with factoring and quadratic formula. So we'll move this 4 over, and it has a like term, this 9. So we can go ahead and combine the 9 and the -4. And drop everything else down. 9 minus 4 is 5. And now our problem's set equal to 0. So we can plug into our discriminant formula up here. We have our a with our squared term, our b with just our variable, and our c is the constant. So we simply plug in our b squared in parentheses, minus 4 times 5 times 5. And I'm going to show you how to do this in your calculator. So what we'll do is we'll put parentheses 10 to the second power, which is our x squared button. We'll use the subtraction button, the 4, parentheses positive 5, and parentheses positive 5 again, and enter. So for this one, we got a 0. So that means we have 1 real solution, or this graph would hit the x-axis 1 time. If we were factoring this problem, both of our parentheses sets would look the same. For instance, x plus 5, parentheses, x plus 5 parentheses, and we'd get the same answer. What happens when there's no like terms when you're trying to set something equal to 0? Well, if we go to add this 10a over, we might notice that there's nothing else that matches it. We have a negative 7a squared and a negative 8, but we don't really have anything with just a. So we know that a squared term always goes first. Our linear term goes in the middle. So we carve out a space for the 10a. And our constant goes at the end and set it equal to 0. We plug in just our numbers for a, b, and c into our b squared minus 4ac. So we'll do 10 squared minus 4 times negative 7 times negative 8. You can do this using PEMDAS by doing exponents first and then multiplying all three of these together. That's 100. And then I know negative 4 times negative 7 is 28. And a positive 28 times a negative 8, make sure you use your negative button, is negative 224. Which if we subtract those two, I believe we are going to get a negative 124. I just wanted to check that. So if it's a negative, if we look at our notes, a negative answer gets us two imaginary solutions. That means that it never hits the x-axis. You could also type this whole thing into your calculator. So you do parentheses 10 to the second power minus 4 parentheses negative 7. So we use that little negative button. Close it up, parentheses negative 8. And then enter, and you'll have your answer as well. So just choose the option that works best for you. Some of these will have like terms, some of them will not. So just being really careful that if it doesn't have a like term, you want to carve out a space for it. So I'll show you the setup for these without actually solving them, so you can try them on your own. We'll add our invisible 1 for number 4. And when we move our 3 over, we need to make sure it's a negative since we're canceling it out and bringing it over. Why did I put it at the end? Because it's a constant. So you would plug that into your discriminant. This one's pretty similar to number 4, and then this one's pretty similar to number 2. So I think we have enough to kind of get a perspective on discriminant. But if you have questions as you're watching this video, just make sure to come in and ask me, and I hope you have a great day.